Welcome back, science students. I hope your projects went well about learning about the different forms of energy. The 6 major forms of energy that we're going to learn about today are mechanical energy, thermal, chemical, electrical, electromagnetic, and nuclear. And then you guys know that, well, based on the law of conservation of energy, that energy can never be lost or destroyed or created or lost. It's basically just going to be transferred from one form of energy to another. It's kind of like this whole idea with the ball, that if I have potential energy, it's not really going to be lost when I drop it. It just gets converted from all potential to now when it's moving slowly down, it still has potential energy, but some of it's being converted to kinetic, and then it's still doing that still down until it hits the countertop. Then at the bottom, it'd be all kinetic energy. It might even bounce back up, and then when it's doing that bouncing, we lose some of that energy to like a thermal energy process. Sound waves are being created. You can hear it bounce. So energy is never really lost. It just gets converted from one form to another. And these are the major forms. Like for instance, if you burn propane, so this would be a molecule of propane. This would be chemical energy because it's stored in these chemical bonds. When you burn the propane, all these bonds are going to get broken. It's going to release that energy in the form of thermal energy. So it's not really lost. It's just being converted from one form to another. Same thing with electrical energy. When you plug in an appliance, it's like, ooh, that electricity just disappeared. Well, no. Let's say you plug in a drill and you turn on the drill. That electrical energy maybe gets converted into mechanical energy. So these are the different major forms. We're going to learn about them. They can go from one form to another. Energy is never lost. So mechanical energy, this is the energy associated with the motion and position of everyday objects. This would be like that drill example. If you fire up a drill that's plugged in, that electrical energy from the outlet gets converted into mechanical energy. There's a formula for mechanical energy. It's the sum of the potential energy and the kinetic energy. We'll save that for a future lesson. Another type of energy is thermal energy. This would be, like I say, when you burn this propane molecule, this chemical energy that's stored in here gets transferred into thermal energy. If you take your hands, you go like this, you're increasing the speed of these objects because it is related to the speed. I'm creating thermal energy. The atoms in my hand are moving faster, so it's creating more thermal energy. So obviously, the hotter the object is, the more thermal energy it's going to contain. So this is a molten metal. It has a lot of thermal energy. So I mentioned chemical energy. We can talk about that again. So chemical energy is basically, you can think of it like potential energy because it's stored. It's stored energy, right? So chemical energy, this is propane, C3, and then H8. When these bonds are broken, that energy gets released to the system and it's available to do work, whether it's going to be converted into thermal energy for cooking or maybe you're using it in a heater, that type of thing. But each one of these bonds, so like a carbon to hydrogen bond, when you break this, it has an X amount of energy. Just like a carbon to carbon bond has an X amount of energy. You would learn about that in a chemistry class. And there is specific numbers for these bonds. So a single carbon hydrogen has X amount of energy. A single carbon carbon bond has an X amount of energy. So just know that each one of these gray bonds here has energy available to do work. And when those bonds are broken, it gets released to the system. So gasoline obviously is, well, especially if you're doing octane, that has a lot of energy stored in it and is available to do work. Wood has a lot of chemical energy in it, so it has the potential to do work. So once you start it on fire, obviously, now is the wood disappearing? Is that wood energy disappearing? No, the wood energy is going from stored chemical energy and being converted into thermal energy. So here's a great example of that. So energy is never lost, it's just converted from one form to another. Electrical energy is another form of energy. I mentioned this with basically any household appliance. A lot of times you're plugging it in and the electrical energy basically gets converted into some sort of mechanical energy which would be available to do work, whether it's your drill, maybe it's another power tool, or maybe it's a toaster. So maybe you plug in a toaster oven, well, that gets converted into thermal energy to cook your toast. So it does get converted from one form to another. Another one we're going to look at is the electromagnetic energy. This would be any energy that travels through space in the form of waves. So sound travels in wave form, light travels in wave form, heat travels in wave form. So those three types of energy travels through a wave. So that's going to be electromagnetic energy. So yeah. So lightning bolts, that's going to be our, you can see the light from it. It actually creates electrical energy. So let's kind of keep working here. The last form of energy we're going to talk about is nuclear energy. So inside of a nucleus, we have energy stored. It's available to do the work. We call that nuclear energy. We could have nuclear fission, or we could have nuclear fusion. Nuclear fission basically releases energy by splitting the nuclei apart. So if you have two nucleuses, they split apart, they're going to release energy. Or we could have nuclear fusion, where these nuclei are going to combine, and that's going to give us a more massive nucleus, which is actually going to then release energy. So both of these release energy to the system. You would learn more about nuclear fusion and nuclear fission in a chemistry class. So, but just know that nuclear energy is stored in the atomic nuclei. All right, I'm going to leave these questions for you guys.